So we're going to simplify this rational expression. So the first thing I'm going to do is take a look at this exponent and realize that all parts are going to be raised to the negative second power. So let's start with 4 to the negative second power. So if I write this on the side, remember that negative exponents, in order to simplify them, you just write it as a positive exponent, figure out what that value is. So that would be 16. And then you take that answer, I'm going to write it as 16 over 1, and you find the reciprocal of that because this negative means the reciprocal of the positive exponent value. So if I interchange the numerator and denominator, it would be 1 over 16. So that means I need to start my answer as 1 over 16. So next, I'm going to be taking a and raising it to the negative second power. So that's just a to the negative second power. And then I'm taking b and raising it to the negative second power. So again, that's just b to the negative second power. In my denominator, I'm taking a to the negative second and raising it to the negative second. Here's where you're using this rule that says if you have a power raised to a power, you multiply the exponents. So I'm doing negative 2 times negative 2, which is positive 4. And lastly, I have b to the 6 raised to the negative second. And again, we're going to be multiplying the exponents. So 6 times negative 2 is negative 12. All right, so from here, I'm going to look for my negative exponents. And anytime I have a negative exponent, I'm going to bring that to the, if it's in the numerator, I'm going to bring that to the denominator. Negative exponents just mean the reciprocal of the positive. So if it's in the numerator, it goes to the denominator. So this one is also going to move to the denominator. And I see one more negative in the denominator that would move to the numerator. So right now, if I rewrite my expression, there's still going to be a 1 in the numerator, a 16, and then an a to the 4th. And now let's take a look at what's going to be switching positions. So the a to the negative second, when it switches positions, it's going to go into the denominator as a to the positive second. When I look at b to the negative second, when it switches to the denominator, it's going to be b to the positive second. And lastly, b to the negative 12th is going to be switching to the numerator as b to the positive 12th. So from here, I'm going to simplify my denominator first. So I have b to the 12th in the numerator, 16, and the thing I noticed first was that these have the same base, and I'm multiplying. If they have the same base and I'm multiplying, I'm using this rule right here, which says you're going to be adding the exponents. So if I add 4 plus 2, that would give me a total of 6. So this is a to the 6th, and then b to the 2nd. One last step in order to simplify this, I noticed that I have a base b that I can combine using this rule, the division rule, and you're going to be subtracting the exponents. So b to the 12th minus b to the 2nd is just b to the 12 minus 2, which is b to the 10th. So my final answer, b to the 10th, it's in the numerator because it was positive, and then I have 16a to the 6th power.